Good morning, everybody. Welcome to another BEPA webinar. This time we're going to take a deep dive on the technology of solid-state batteries, its past, the present, and what is the future for Europe. I see a lot of people are still connecting, so I'll give them another minute or so before we really dive into the meat of this webinar. So make yourself comfortable and we will start shortly. Good morning to everybody who has joined us just now. We are still waiting for the last people to join us. We'll start in a little minute. We see that the ticker is still ticking up. People are still joining. So thank you for joining. We'll start in a few seconds. Okay, well, let's go. Everybody, welcome again in this BEPA webinar series. We have done quite a few over the past year. We looked at raw materials and recycling. We looked at battery systems for different transport modes. Today we'll look a little bit more into the chemistry, into the black magic, as I've once called it, the black magic of batteries. And specifically, we're going to look at solid-state batteries. How far have we come? What is the status of today? And what will they bring for the future for Europe? So first, let's me introduce the big picture. We will have a welcome and an introduction. Then my colleague Bozer Kambai will give you a very nice update on where we are right now. And then we dive into a discussion with a very interesting panel consisting of both the research angle, we have a startup represented, but also the European Commission is here in the shape of DG RTD, and some value chain wide advocacy groups as well. So very broad representation. Of course, there will be the possibility, as always, to ask questions. Please use the Q&A function in the top of the Teams app to ask your questions. I will then look at them and pose them to the panelists. As always, the slides will be shared with you afterwards, so no need to ask. You will be able to get them. Yeah, for the rest, I wish you a very pleasant session. So let's start off with the beginning. Why are we here? Of course, at BEPA, we support battery research and innovation in Europe for multiple reasons. Of course, to make our own industry more competitive, not only the battery industry itself, but also all the end-use applications that need new batteries, ranging from electric vehicles to stationary storage to even, of course, defense, Internet of Things. There's many applications for batteries. Providing batteries in Europe will help with the strategic autonomy, with our energy security, and also allow companies and private citizens to have affordable and clean mobility and energy. Of course, we will try to do this with as low emissions and toxicity as possible. So what has BEPA done so far? Of course, we are the private part of the Bat4EU partnership together with the European Commission, in which we help to co-program the funding on batteries coming out of the Horizon Europe program. My colleague Bozorg will also touch upon that in his presentation. And we also help to create a broad and excellent R&I community in Europe. Many of you are already deeply involved in, so thank you for all the work you've done. We also publish a strategic research and innovation agenda, not only for the partnership, but also that can serve as a wider inspiration for the whole of Europe. And we do also organize a lot of events and provide the launchpad for battery startups, trying to give a profile to those companies that really are at the verge of breaking through. So what have we supported in the partnership? Many new cell manufacturing technologies, both the older generation of liquid electrolyte lithium-ion batteries, but also newer chemistries, including solid state. We have been deeply involved in the deployment of AI to discover new battery materials, trying to accelerate this whole process of finding the new chemistries. We have developed novel materials, processing and recycling, also with the end of life. And of course, help provide batteries both for mobility, but also for the future smart grid. Of course, we also host one of the Europe's leading strategic battery events together with other European entities like Battery 2030 Plus and the important projects of common European interest. This year's event will be in Graz in Austria, 2 to 3 December. So if you're looking for a nice Christmas break, early December, please come to Graz and also join us for the Battery Innovation Days. So if you're interested to help us do all this, please join us. And for now, I will hand the word to my colleague Bozorg Kambayi, who will dive straight into the current status of solid-state batteries. So Bozorg, please take it away.
Thank you so much, Walter. Good morning, all. Welcome to our webinar. I try to be efficient with the time because this is a very wide topic, but in essence, what we are going to talk about in the presentation is mostly just have an overview of the technology, see what's the position of the Europe, what have been done, and what needs to be done, and also a bit of an overview of the challenges, just scratching the surface a little bit of the many challenges that this technology exposes us to. So just a little bit of a context and background about this technology. If you have not been living in this crazy battery world, this technology has been called a lot of names, Holy Grail, the solution, etc., over the past at least couple of decades. In 2010s, there were a lot of promises. Some OEMs actually went to the lengths of postponing the electrification of their fleet. With the notion that the only technology that satisfies their range anxiety is the solid state, and we will get there very soon. Well, that didn't work out as we hoped. That's the truth now, and that's the picture at the moment. But fortunately, the physics doesn't change, and the potential is still there. And this is a technology that promises a lot of things, but at the same time, it's very difficult. So really, our job, our association and partnerships mission, in essence, is to consolidate these two premises, that a very high, ambitious technology that also the future of the European, first and foremost, automotive sector, competitiveness, and also other sectors' future depends on the progress of these technologies. So that doesn't really change throughout the time. At the same time, this is very difficult, and this is a very kind of a challenging technology to the extent that Professor Martin Winter mentioned that the next person that figures out how to work it out deserves a Nobel Prize. So again, this is a consolidation of these two very different angles. So what is the technology itself? I try to be very brief in explaining that. What we have at the moment is what we call in the SRIA and our previous works, generation 3 liquid electrolyte lithium-ion batteries. What we want to achieve is the moving from left to right. We are talking about the spectrum of technologies. There are intermediate solutions like semi-solid batteries using electrolytes, using liquid electrolyte to facilitate the problems at the or alleviate the problems at the interfaces. For those of you who are not, like me, a battery expert, the essence here is to maximize the amount of those green particles that are carriers of the lithium that introduce lithium to the system, and minimize everything else. At the same time, we want to increase the capacity of those green particles in a sense. But this is a very difficult job. The one solution is to introduce, instead of liquid electrolytes, solid electrolytes. It helps us with the safety a lot, and also gives us the ability to minimize the volume and weight of the other particles. So we are thinking, just a very raw notion is that we are talking about a spectrum of technologies, a portfolio of technologies. Those solid electrolytes are not one thing. We have at least 3 main categories of them, different in performance, different in manufacturability, different in the cost points, etc. And given the diversity of other components, we are thinking about a very diverse portfolio of technologies and applications and batteries. What we are today is somewhere in between. So we have limited adoption. Some cars and some EVs in China have been deployed with semi-solid batteries. But the right-hand side, what is called the old solid-state batteries, and the very futuristic anode-less lithium-ion batteries, when you have virtually no kind of a constant anode, and the anode will be somehow it's a breathing cells with the deposition and stripping of lithium metal. That's very futuristic, but really disruptive. Important to note that these, going from left to right, we are thinking about a potentially safer. So that word really matters. These technologies are potentially, we have not achieved there, more or less on some points, but we have not have the comprehensive system that checks everything. But we are thinking about a cheaper cell. We are thinking about a very high performance cell, and we are thinking about the potentially very safer cell. So very much, again, what checks the idea of a holy grail, at least at this stage in the battery world. So let's talk a little bit about the challenges, why we are still thinking about commercialization of a product that we thought would be doable many years ago. One part is a scale, and one part of a scale is the product itself. So to really unleash that potential, we need the cells to be high in a very general sense, have a higher capacity. That really helps with the manufacturing, that really helps with the cost, that really helps with the integration and the performance points that at least automotive sector needs. The pace of that progress is compared to liquid electrolyte is much slower. This image is a little bit illustrative only. The technologies are different in a sense, but just to make the point that the rate of the development in terms of cell capacity and compatibility of all those components in the cell is much more difficult in the solid-state electrolyte. But we don't need cells for having cells. We need cells to have EVs, and the integration is also important. The integration of those cells into any kind of system level architecture, modules, packs, and the vehicle itself. More opportunities because of higher safety, but a lot of new challenges because of the lithium metal as a main component in the future cells. And it's to suppress its dendrites and side reactions that is happening there. We need pressure. These kind of strategies need really new solutions. We don't have it at the moment there. So the product itself, just making it integrated and to the size that is competitive is a very huge challenge. That might be the big solution of this technology. But also at the same time, the manufacturing of solid state batteries are very tricky. Main point here is that what we are producing at the moment as Gen 3, as liquid electrolyte, is not satisfactory for this technology. They share almost 50%, but for the remaining 50%, we need new manufacturing, new processes, new machinery, and everything else. The advantage here is that we can at least use the existing infrastructure to some extent, but the flexibility is very important. That's what we have actually funded in these years, and that's the point of the innovation that needs to be addressed primarily. The other point about the manufacturing is the cost of it. So whatever system that we want to deploy needs to be competitive. That should be on the top of the agenda, and that competitiveness comes from the cost points that at least for the passenger electric vehicles is feasible. At the moment, because of the complexity of the manufacturing of these systems, the costs are higher. The absolute costs are higher. More energy is consumed, more processes and machineries are used. But if we can get to the scale, and that's the tricky point, if we get to the scale because of the higher energy per unit that these technologies provide, we are thinking we will get to a more moderate and even lower than current technology. But that higher absolute cost really means that the ramp-up costs, so the years that we will produce scraps or non-efficient cells, or we are ramping up, we are figuring out the design, that period of 2, 3, 4, 5, whatever years will be costlier. That's the definition of the value of that. That needs more funding, that needs more attention, maybe costlier if we thinking about the scale of the current generation, much costlier than the current generation, and needs much better support. That's a point that should be noted here. But cell manufacturing is not everything about this technology. There is a lot of provisions that needs to be addressed at the upstream and downstream. So we are introducing new material to the sector. These materials need their own value chain. We need kind of a more ambitious raw materials and advanced material strategy if you are thinking about new chemistries. That has been the lessons learned from the lithium-ion batteries, and that has been addressed in the critical raw materials. But moving forward, we have to keep in mind that the case will be again repeated for these technologies. The chemical industry's legacy and strength in Europe is unquestionable. There have been bumps on the road, but the maturity of the knowledge and technology is really there. This is a very good opportunity for us to build on that and to use that for these futuristic technologies. Also on the downstream, there has been established kind of a pathway for the qualification and for the testing of the systems. We are becoming better in making it more efficient, doing more parallel activities, but innovation again here is needed. To make sure that we are using the more standardized, more digitalized, and more kind of advanced testing methodologies to minimize the time to market as much as possible. This is a very difficult task, and it's ongoing in many European projects. About the scope of the activities, the challenges that come with the scope. So these are a little bit of the externalities and overlooked aspects in the field that we noticed happening very frequently. So very timely with the announcement of the new CATL battery cell for electric vertical landing systems. So the idea that these technology is there to just serve EVs is not really the case. The potential that is there in terms of the safety, in terms of the energy density will really open up new markets that has been a little bit overlooked. We have been informed by other entities within the European Union about the potential that and the kind of opening that the potential of this that is the potential of this technology provides for them in the aviation sector. In the defense, there are a lot of spaces that these technologies can cover. The next generation batteries, again, the components of the solid state battery are usable for other chemistries, such as lithium sulfur, for instance, too. So there are a lot of opportunities there, untapped in many areas. And if we sleep on a couple of years, maybe we will be faced with kind of a new eras that we have been missing. So that's a bit of a threat from our perspective. On the other hand, the technology itself and this complexity and the sheer magnitude of the expertise and knowledge that is going into these areas really opens up the opportunities for chemistries behind the line. Just an example from the Professor Pazzarini here about his new idea about the seawater batteries, this technology that he has been very much worked on. And he mentioned that the main challenge with this technology is not actually the sodium and other components itself, is the electrolyte, is that thin electrolyte that he was waiting for from the maturing of the solid state lithium-ion battery technology, and that didn't happen, and that's what's keeping it still waiting. So this is a very important point. The spillover is there. We are with hesitation in developing the solid state batteries. We are at the same time blocking the way for other technologies on the horizon. That's very important to keep in mind. So about the speed, the challenge of the speed, and nothing can make the point about the speed that the global competition better. A lot of things are happening around the world. In China, the pioneer at the moment in the field, the government actually consolidate the efforts under the national all solid state battery initiatives with the funding close to, just to give you a rough idea, close to what we received at the Bat4U partnership for the entirety of the Horizon Europe, that will be dedicated to one technology there. There was a new safety guidelines published last week that will be into effect in July, I think, 2026. Very high standards, opens the market, and again incentivizes hugely the solid state batteries. So we see how the policy instruments work there. I skipped a little bit about the semi-solid and the controversy about it and the promise that it provides, but we have to keep in mind that there are cars in China using the semi-solid state batteries. Just important also to keep in mind at the same time that we don't have many cost figures about how cheap they are, and also the exact compositions are unknown. But the energy density, as I mentioned, we don't need cells for cells, we need cells for better cars. That has moved forward a lot the competitiveness of the Chinese players using the semi-solid state batteries. So semi-solid still is a solid state batteries. You need to manufacture solid state batteries, but you overcome the interfaces with liquid electrolyte. It still doesn't mean that these are not very advanced technologies. A little bit about the CATL. You might have seen the tech day the other day, but a bit of a more realistic vision coming from the CTO, that at the moment they are thinking about TRL4. Again, the definition of that and what they mean really about TRL4, TRL7 or 8 might be different, but they are thinking about 2027 and later about the commercialization, really getting that into the market. On the US side, the Department of Energy, the ARPA-E program has been very well funded. This next generation battery through Battery 500 program, through battery to 1K, proper 1K, the new program that is going for the 1,000 watt-hour per kilogram, really opening up the market for new applications. IRA and the funding, the $6 billion in the funding under the Biden administration is a huge number. IRA might not work for the solid state batteries because of the timings and deadlines that it had, but $6 billion The two round, the second 3 billion was really focused on the next generation. Still a little bit unclear, maybe not a little bit, but unclear how it will pan out under the Trump administration. But US, the case is always there that the capital is there. The access to capital is much easier, and the big companies, the more frontiers at least in the 2010s come from the US, and the major European OEMs have partnerships with them. Japan and Korea. Japan has been the main pioneer coming many years ago. They have been a front runner in terms of the technology and knowledge. South Korea, a lot of programs from different companies on this technology, and they always have the leverage of the scaled up lithium-ion battery production. So there's a huge accumulated expertise there. So that's indisputable. About Europe, so about the cell companies, at the moment we have the only European headquartered solid-state battery company is Blue Solutions. They actually are one of the first in the world. That's good to hear. Started in 2010s actually. Moving forward with the polymer electrolyte, going to the next generation in their roadmap to lithium metal, etc. So there's a good progress there. There's another company that will very likely start production and actually supported by the French government to produce semi-solid-state battery, Prologium. It's headquartered in Taiwan, but they will start production in Europe in a couple of years. Other than that, we have many good startups, small companies that have reached the prototype. Sorry if you are coming from a company that you don't see yourself the picture here. Just the point here is that we are not really at the manufacturing level for the other companies. Most of them are at the prototype or very small pilot level production, but good results, good cells, a lot of potential and promises there. We are to the previous point about the spillover. We have new, even sodium solid-state batteries doing very amazing things, providing the opportunity for different working environment. So really showing the case that the spillover argument is there and will help in the future. The situation at upstream is not as good. We have very limited production of the solid electrolyte itself in Europe, despite again the very high potential of the chemical industry there. But on the downstream side, the major European OEMs have partnerships. Sometimes it's been presented as the main solid-state partner, but they are all American. These American companies have also a lot of partnership with Korean companies or Japanese companies, so it's a complicated scene, but that's the case, at least on the downstream for the moment. So let's get to what we do and how we are supporting under the Horizon Europe, under the Bat4U partnership program, the solid-state battery projects. So first of all, we have put a good chunk of our budget on the solid-state, either directly or a little bit indirectly through other projects. 20 to 30% of the budget that we have developed so far has been dedicated to the solid-state batteries. Important here to observe the fact that we started with high KPIs, product level, cell and material, suited for the EV application primarily, very high KPIs, very ambitious goals. But we are moving toward kind of a more scale-oriented view. We want to go with think much about the industrialization, the first deployment, the scale-up, and the shape of the projects, the objectives of the projects have been adopted. So we are thinking about scaling up and co-development, so really engaging the upstream actors and downstream actors, OEMs, to have a say in the manufacturing, in the development, in the design. Also making sure that what is intermediate products that might not necessarily fit for the EV application, there's a potential, the potential for using in other application, has been addressed. So diversity of the application is very important for us moving forward. These topics on the horizon have been followed up by a very interesting number of projects. We need much more time to discuss them and get to them. And very interesting results from different applications in terms of the technologies, in terms of the manufacturing novelty that they are developing on the lithium side, on the cathode side, on the electrolyte side itself, on the integration. We will get to the first batch of concrete results in autumn. Please make sure that you will be with us and really observe the amazing result that these projects have produced. So on the political side, just a couple of slides on that. What's the thinking at the EU level about next generation technologies? So we have the EU Clean Industrial Deal, really making the business case at the EU political level for the clean tech non-price criteria, incentives in terms of the public procurement, state aid approval. So we had very extensive conversation in our last webinar about that. I put the link for you. You can go and see what's exactly there. In this year, the EU will also develop its startup strategy. That's very important to the cell makers. As you saw, that a lot of them are still small companies. That's very crucial for them moving forward. The burden of the regulation. We had a survey from our members and the startup community at large in Europe, battery startups, to see what are the challenges. You can also see the link to the results of that survey, but very much in line with what is pending at the EU level to be prepared for these documents. The automotive strategic plan, action plan for the automotive sector, that has also been published a couple of months ago. That we have a better say. We are seeing that the mentioning of the partnership and mentioning of the next generation battery as the main alternative for the future struggles of the EV sector in Europe. That's very good to hear, and that has been acknowledged. Great news for the community in general. We have also other incentives and other provisions about the funding and supporting from the EU level and member states level on the projects of the battery production and battery manufacturing and next gen. Again, we have discussed it in our webinar, so you're welcome to go there and see what's in detail there. Wrapping up with some suggestions from our side, some points that we observed throughout these years of the Bat4U partnership. So first is that, as you saw and as you know, it's very difficult to distinguish between the stakeholders in such a technology like solid-state battery as the next gen's battery. Very difficult to supply some raw materials from one and manufacture it yourself and someone else deploy it. This is much more entangled, physically even, and also strategically, and also economically. So whatever that we are going to, whatever program that we are aiming for the next framework program or competitiveness fund, all of those promises. Important to note that this is there should be a value chain perspective on that, and we cannot really distinguish the parts of the value chain and work on them separately. And of course, we have been an instrument in making that value chain, the structure, and concreting the relationship between the stakeholders within the innovation era. And user diversification. So mentioned before, the scale-up cost and the ramp-up cost is much higher for the solid-state batteries, but the product, the scaling of the product can be minimized. That smaller cells, cells that are produced at a much higher cost, can be the case for use in other sectors, other technologies, other applications. They can accept much more higher cost points. That's a good point. So that's a good strategy to absorb the ramp-up cost, at least part of it. for these technologies. This is a very much the high advanced material, advanced chemistry, and advanced manufacturing sector. We have a good legacy in the chemical industry. We have a very good legacy in the semiconductor business. Companies like LionVolt are working on that, using that knowledge to work on the lithium metal, for instance, on or electrolyte itself, electrodes itself. We have to build on that. That's a must moving forward. We cannot really. These are not the knowledges that we can import. We already have it here, and very difficult even if we want to get there. So let's build on that. Let's make sure that they are as much as possible involved in the future of the advanced chemistries. So despite the kind of a progress and the news that we see outside Europe, still the game is open. It's not done. Maybe the notion that is more valid about the liquid electrolyte is not the case here. And we can the diversity of the manufacturing, the diversity of the product, the components itself really has not been converged into one solution and one winner. We still have a good time to catch up, if you will. The core business is the core business of cell manufacturing is still very small, again, because of the fact that the technology and the manufacturing has not been fully figured out. Maybe the kind of a rapid expansion is organically not possible at the moment. So a lot of these companies are startups. Access to capital is super important. The speed in the funding process is very important. So a very well-designed and well-prepared US startup strategy will directly affect these actors, and somehow the future of the European battery sector and to large extent EV sector depends on these actors. So we have to make sure that they are provided with the best policies and instruments. About the research, many points, but just very, very core responsibility and potential for the RTOs and universities. Just a very simple point that we have this infrastructure in Europe about the characterization. Very important tool to solving the issues with the solid-state batteries, specifically on the interface and also on the lithium metal, etc. We have that the good opportunity for the RTOs and university to leverage that. The good opportunity for the Europe as a whole to leverage that and to make use of that for the advancement of the technology. And the last point is that the industrial action plan for the automotive sector mentioned the next-gen batteries, but at the moment, as we know better, the OEMs are very much consumed with the liquid electrolyte, with the current generation. Still, a lot of their resources go to the innovation, if not sheer scale up and manufacturing of these batteries. There is little left for working on the next generation batteries. That's where the public funding should come in. That's the very definition of the value of that, and the parts that the private side cannot really simply afford, and the public side should pitch in. So I leave that point to one of our guests, and the others to many other experts in the panel in terms of research or startups and the policy. So with that, thank you so much, and yeah, enjoy the panel. Thank you.
Thank you much. Thank you so much, Bozorg, for the excellent overview of the different technologies, different strategies there, but also the political landscape, at least in Europe, where we're heading, and what we need actually in terms of support. So very well done. I think standing ovation with hand claps in the bottom of the screen. So I think that's deserved. Now let's discuss all this with some of the key stakeholders in this area. We have an interesting panel. First, let me introduce Fanny Bardet, founder and CTO of Solitor, one of those key startups in the area. We have also with us Gwen Giffen, scientific head at Fraunhofer ISC. and as well Johan Blondel, Policy Officer of the European Commission at DG RTD. And last but not least, Thomas Otajewski, advisor at the Solid State Battery Coalition here in Brussels. Let me see. I don't know if Gwen has her camera ready. She had some internet struggles earlier. Yeah, there we go. Thank you all for joining. Gwen, let me start with you. Bozorg said, okay, many technological challenges still left, a role for RTOs. What do you see in terms of the solid state technologies and components? What are you working on within ISC and within the wider European projects?
So some of the things, thanks by the way, Volta. Some of the things we're working on is sort of the bridge between materials and processes, and also then how to understand what's happening, so also diagnostics. So we're involved in a couple different EU projects at the moment, including two of the ones that were on the slide from Bozorg, so SpinMate and SolidBat. Here we're looking at everything from optimizing materials with coatings, cathode material coatings. We're also looking at new processes for solid state. We actually just have a new let's say pre-pilot line technology platform where we can use materials and start looking in more depth at the processes. And one of the things that we also see in the future is that we need to find ways to analyze what's going on in these processes much better. So using new types of techniques, maybe things that haven't been used as much in batteries before, for example, and to apply these to manufacturing, and then also to apply them to understand degradation in the cells. So these are just a few of the different things in the solid state space that we're working on at the moment.
Yeah, and you also see then that integration between material development and manufacturing that Bozorg mentioned in this sphere.
It absolutely so integration of the materials manufacturing and the process definitely needs to happen, but we're kind of still to a certain extent challenged in the fact that we need materials on a larger scale. So we can look at materials on the small scale and look at the processes on the lab scale, but we know this is going to be a big jump. So at the RTR in Brussels in February, one of the comments was solid state batteries are probably going to be made with different manufacturing processes than we're using for lithium-ion technology. And this is a challenge, but this is also a chance for us. And so we have to be able to really do research on these processes and understand how they work and figure out how to make them scalable. But to do that, we have to have materials that are available on at least the kilogram scale. And this is something that's really challenging, particularly for us as RTOs. If you have, so like Solitor, a startup where you have your own material, you kind of control the scale that you can produce at. But for us, we have to be able to get our hands on these materials. And this is still something that's a bit of a challenge.
Yeah, well, excellent bridge towards Fanny. You heard a CTO and co-founder of Solitor, startup in this area. What are the hurdles that you face with Solitor to bring this technology to the market and going from prototype to production?
So good morning. Thank you for the invitation and the questions, Walter. So yes, indeed, at Solitor, we are developing next generation solid state battery. The main hurdle, I mean, of course, there are several hurdles we are confronted with, but I would say, first of all, the access to capital is really, I mean, it has been presented earlier by Bozorg, but access to capital is a challenge, especially in the current situation, especially the last 2 years, I would say, with what has happened in Europe in those big startups. So, and there I want to mention that actually it's a domino effect. So in order to get access to funding, of course, you need to, typically your private investor, they want to see strategic investor coming to the table because they want to be really sure that the technology you are working on makes sense, is upscalable, and has a promise. And that's always the kind of the chicken and the egg story where you have private investor already, but they want to have a trigger from a strategic putting money on the table to and then they will double the amount. And I think this is the situation most of the startups are in. You really have to bring players from the battery value chain around you. It can be a car OEM, it can be an equipment supplier, it can be a chemical company. In our case, we are of course looking at all of that, but that's one of the big challenge, to bring those people around the table and to invest in your company. So that's one. A second point I would like to mention, of course, is that assume you get your funding right. Obviously, you have to execute according to your timeline. So building and executing a strong executing team is really very important. And there I want to mention also the right level of industrial expertise. We have a lot, of course, of talent in Europe. We have a lot of graduates, a lot of research institutes with PhDs, but the industrial expertise is still on the low side, I would say. And indeed, when we look at upscalability, so when you go from a prototype to mass production, you have to start to work on quality control. Indeed, when you go from kilos to hundreds of kilos, and in case of electrolyte, when you go to a few centimeters square to start to make roll-to-roll process with kilometers of scales, you need to make sure your material is good in terms of quality control, in terms of thickness, that you control of that on large area. And this is where potentially expertise needs to grow up, I think, in Europe. So that's a second point. And finally, a general comment on public funding. I think, yeah, Europe is there, and there are a lot of instruments. Actually, maybe too many instruments, according to me, which makes for a startup like us, we have limited resources. So you really have to find your way in the forest, the tree, and to see the trees in the forest. And the instruments are typically made for very large projects. So typically you have this big project with 15 partners or more. And basically, maybe it might be good for Europe to think about having some new instrument where you could have more focused topic, where once you are at TRL 5 and you want to go to 6, 7, 8, that you really combine expertise around, like, for example, chemistry, a chemistry company, a chemical company, a startup with his new product, and potentially a RTO. So a small consortia where you really focus on how to upscale that material. That would be, and you really focus, and you can really leverage on each other's expertise and be complementary. The startup coming with its new material, its new activity, but maybe the chemical company coming with its knowledge on how to industrialize and grow a reactor of few hundreds of kilos of material. So there potentially there is an area for growth and to facilitate our job as startup to make that gap, to bridge that gap from TRL 3 to 6, 7.
Yeah. Maybe if we're talking about the forest, the skills issue is also very interesting. Maybe we can touch upon it later, but let's talk about the forest. Maybe we should move to one of the sheriffs in the forest who can tell us about it also. We have with us Johan Blondel, policy officer at DTRTD. Johan, what kind of funding instruments are there to help these kind of breakthrough technologies as solid state battery chemistry? There are many, as Fanny said, but which ones are you highlighting?
Okay, well, first of all, thanks for the invitation. Happy to be here. I take the point of Fanny. It is indeed not always easy to navigate through the different instruments, which is also why we rely on, for instance, Batteries Europe, the ETIP, to help provide guidance, and BEPA also plays a significant role in this. But I would distinguish the different funding schemes in terms of the TRL levels. So at a very low TRL, when you're coming up with new concepts, we have the EIC, especially the Pathfinder program that is available there to help develop radically new blue sky concepts. Then when you look at the middle range, that is the sweet spot where both BEPA and the Commission are working in this partnership. BAT4EU, we cover roughly the range from 3 to, let's say, 7. So advanced demonstrators, because we are limited by the budget. As everyone knows, the higher you go up in TRL, the higher the budget that is associated with it. And then when you look at the highest TRLs, so really getting ready for introduction to the market, well, we have the Innovation Fund that is has a lot of budget available through the emission trading system. So now there is 3 billion set aside for the production of EV batteries, and this is put more into evidence through the battery booster scheme that has now been announced for 1.8 billion for the manufacturing. But there is also the EIC accelerator, that is a mechanism to help especially startups move towards deployment. And that goes hand in hand with the EIC fund, because the problem that Fanny mentioned is leveraging a private investment, and that is where the EIC fund comes in. So they put cash in to startups, but then they also try to crowd in private investments. And typically you get a factor 4 of leverage there. So for every euro that EIC fund puts in, you get 4 euros from private investors. And that helps. So far, 2.6 billion have been leveraged in this co-investment scheme since the start of the EIC in 2020. So I would say this is more or less the range of instruments that we have at our disposal in the current multi-annual financial framework, of course, that runs until 2027.
Okay, thank you, Johan. So this is what we have for now. Of course, with the next budget, probably don't know if we will see a simplification of means, but at least some clear distinction in terms of who does what around the TRLs. Thomas, you are advising the Solid State Battery Coalition. Can you tell us a little bit about this initiative and what its aims are?
Yeah, thanks, Wouter, for the invitation. So we are basically a group of companies and RTO trying to create space, let's put it this way, in the current instrument to fund solid state battery, because I think we saw this in the previous slide prepared by Bozorg. We have good hopes for the next budget, but if we wait for the next budget for this industry, we are done. Let's be clear. When you see the timeline in China, the announcement of CATL and BYD in the last weeks, we can't wait for 2028. So we need to create space now in 2026 and 2027 to make sure that we can fund SSB project, next generation batteries project. Otherwise, we will lose again some independence towards external partners, and I think it's not good, especially in the current environment. So it's really important to push for this and to move forward.
Yeah, and what kind of concrete policy and funding gaps do you need to be addressed in order to achieve this growth?
I think there are several tools. I think Fanny and Johan somehow mentioned the tools where we can create space. I will add one, but the main issue, for example, when we talk about the European Innovation Council today, but this can be changed tomorrow, is that if Fanny, who is a startup, is trying to go in the EIC, she will compete with very different kind of projects. She will not compete only with battery projects. And for example, in the EIC now, in 2026, there should be a specific challenge to help startups to develop their pilots. This should be one of the priority. When it comes to the Innovation Fund, because Johan mentioned it clearly, if you want to move to the first industrialization, the Innovation Fund is great. But today, if you are an SSB project and you are entering into the innovation fund, you apply, you will certainly lose at the cost criteria. Because you are so innovative, but your CapEx and OpEx are so high that when you will put this in front of your greenhouse gases reduction, your project won't be funded. And it's a pity because it's very innovative. We see the others putting a lot of money, but we need to revise some of the criteria to create some space for these projects that are strategically important. Last but not least, and this was not mentioned, I think solid-state batteries can bring a lot of values for the defense industry. We saw that, we see the potential, and therefore we should discuss at the defense fund level to help to finance some R&D, because again, do we really want to give away this part of our defense to external partner? I don't think it's the case, but we need to take the right decision to make sure we can have European batteries for European defense. And this is very important.
Hearing that and saying, okay, we need to look at the tools that we have at hand now to see what we can do. Johan, with your view on the BAT4EU partnership, how do you see the involvement of the solid state projects and future priorities listed within the partnership?
Well, Bozorg already hinted at it. The problem for solid state batteries and startups in general, I think, is very difficult, in the sense that you need to build up the value chain. You need to build capacity also for the materials. You need to get the manufacturing equipment also on board. And you also need to create a link with the end user. Because it is very important also for a startup to know that there is a potential client who is willing to take up your products. So that is what we are taking into account now in the development of the 26-27 work program. The aim there is to drastically reduce the number of topics and to create larger and more impactful projects that really bring together this whole value chain, including the end user. So in this way, we can assure that all of the KPIs that are being worked towards in the projects, they're really relevant towards the end user, and already build up this future takeoff chain, so that there is already a window for the expansion. Aside from that, of course, we have our own envelope, our own budget that is available for BAT4EU, and that is limited, unfortunately. What we can do, of course, is to seek synergies with other initiatives. So, for instance, the Advanced Materials Partnership that is now starting up, but also Made in Europe. Excuse me, the partnership on manufacturing. We see a lot of parallels between what we do and what they are doing. So we are exploring ways to get meaningful collaboration together with them, and try to leverage a little bit of funding from their side as well. Apart from that, it was already mentioned, we have the action plan for the automotive industry. We have the Clean Industrial Deal call. That is also mobilizing 600 million euros now for the period 26-27, really looking at fit for deployment technologies. And I think there will also be an opportunity there to fund solid state scale-up projects.
Okay, interesting. So yeah, lots going on. All about impact, you say. So Gwen, with your experience in the ongoing projects and what you're doing yourself with your pre-pilot line at Fraunhofer, what do you think are really the bottlenecks, both scientifically, engineering-wise, that we need to overcome to reach this scalable solid-state solutions.
There's a number of different things. I'm going to try to organize them a little bit first with the scientific side and then with the engineering side. So Bozarg mentioned earlier interfaces. Interfaces are really the key to a good functioning solid state battery. When we think of lithium-ion technology, compared to solid state, we simply have less interfaces. And even after years and years of research, there's still things we don't understand there. And so it's the same for solid state. We have to understand the interfaces. To do this, we need to have, as Bozarg also mentioned, the large infrastructure, the characterization, and we just need to keep working towards what changes with the interfaces. And then this ties also moving towards, let's say, the most advanced technologies that we would hope would be developed, including the anodeless technologies. So basically, I mean, anodeless is a bit of a misnomer for the non-battery experts. It basically means you manufacture the cell without lithium metal and assume that all of the lithium you need is coming from the cathode. So you do have an anode, it just starts out in the cathode. And we have to have good control of the interfaces, particularly in terms of stability, efficiency, and degradation to make these kinds of technologies possible, which really are going to push the envelope in terms of energy density. One of the things that has always been a promise of solid-state batteries has been safety. And I'm not saying that this is right or wrong. All I'm saying is we just don't have enough information. To get to this point, we have to have large enough cells in a sufficient number in order to have good statistics. I mean, we mentioned, Bozarg also mentioned earlier, the new regulations coming from China in terms of safety, which basically says no fire, no explosion at all. And we have to be able to understand what happens with these new chemistries. You're talking about lithium metal. Lithium metal can melt if we go to thermal runaway. What's going to happen? And so in order to really understand what's going to be the true safety in not only a cell, but also in packs, we have to be able to have sufficient testing. And to do that, we have to get to Series A, Series B cells. We have to get to this point. And so that kind of leads us to the point of materials and manufacturing. I think we've already kind of covered the materials point and also the manufacturing to the point of view that we have to build it up. This is going to be new processes, and we have to understand how they work, how we can do them efficiently, and how we can run them at scale. And as Fanny mentioned, this going to the running them at scale is a huge, huge, huge challenge. But we have to be able to do the first steps first and implement all of the necessary quality control along the way. And then finally to the use. So basically, what did the systems look like? And this is a close tie back to one, we have to have a good system safety to basically make it a good promise for our end users, basically to get the social acceptance. And the other thing is there's new technologies, new concepts that are needed, particularly in terms of pressure. This is something that is not as big a deal for lithium ion. We don't need the same kind of pressures for lithium ion that you need, at least at the moment, for solid state. And so how do we integrate this into a pack? And here we also see the challenge again of we need to build up the value chain from beginning to end. How do you effectively build a system when you don't have a solid state battery to build it around? And this was also one of the things in Brussels in February where the projects looking at systems had to basically source batteries from somewhere else in order to be able to build a system. And so we have to be able to build up the whole value chain from the research perspective, from the engineering and upscaling challenges, all the way to the system and product to be able to put it into whatever the end use is. I know that's a lot. But I hope it was organized in a way that at least you can follow.
No, it's very clear. There's still challenges on multiple levels, and we need to grow what we're doing on certain levels to get the results in other ones. So I think it's very integrated, but I think that it was a very clear description. So thank you so much. Fanny, turning back to you, Johan also mentioned like the KPIs and defining actually what we want to achieve with these solid state cells. So how do you evaluate this possible trade-off between performance and costs, the manufacturability as a startup? So like, how do you come to your ideal product and does that change along the way, or is you just go out to a plan to achieve one thing and then go for it?
Very interesting question, Walter. So indeed, I would say if I would have to, you ask performance, cost, manufacturability. Of course, everything is important. We have clearly indicated that. But as a startup, you have to talk to investor, potential end users. Performance comes always first. They always want you first to show a proof of concept cell prototype which deliver a unique, let's say, or high performance, being high gravimetric, high volumetric, high current density, ideally all of that. There are even, let's say, end user or investor, they don't talk to you before you have not reached the 500 cycles. That's the reality of the market since we are in. I think 10, 15 years ago, startup had a different life, I would say, because the expectation also is that were still fresh. Today, people, I mean, there have been a lot of players in the field, not yet fully commercialized products. So people are much more asking upfront before even talking to you. Show me what you can do upfront, and then we talk. So I think that's a reality of the market we are facing. So for us, performance has to be on the first talk. We have to show something unique. And I would like to say, of course, depending on the application also, because in the past, maybe it was more automotive driving, all of that. If you go for very high performance, such as solid state battery, of course, you can you can go to other field like aviation. I mean, I'm talking aviation, defense in general, and space. But also maritime, they also have interest, where basically gravimetric performance are very important, but also safety. So you see really for high performance batteries such as solid state or solid state battery, these are new markets, but also with new mission profiles. So it's not maybe the charging speed which is important, maybe more the discharging speed. So for all of these different end users, you have different mission profile, and as a startup, you have to learn very fast what your cell can do and try to fit your cell to the best market at the moment you can deliver certain performance. So that's first. I would say within the KPI, also safety, as mentioned by Guinevere, is very important. Again, 12, 15 years ago, people were just saying, okay, so the battery will be safer. But today, people are really saying, show me that. And it's not just with a nail penetration test that you could go through. You have a full set of tests you have to go through with your cell and to show at the material level in cell. And indeed, as mentioned by Guinevere, you have to have a certain capacity of a cell to be able to demonstrate safety. So again, safety is one of the criteria, and there are many different tests, and there is not so much actually literature or reference benchmark on that, especially for solid state lithium metal. And probably all these different chemistry are shown by Bozorg earlier. So solid state, we always talk about solid state, but actually it's a portfolio. You have lithium metal, lithium free, you have semi-solid, you have oxide sulfide. They will all behave differently, and your cathode, put the cathode there, LFP versus NMC. So it's a whole new portfolio of safety tests which has to be done. And at Solitor, we decide also to actually do our own safety tests because we need to understand our chemistry and from the start. So we have actually invested in some safety test installation. The second, which will come, I would say manufacturability is coming second for us. And again, why? Because this is a question also coming very fast to us, like because of the past, over startup, over groups working on solid state, actually they kind of struggle mostly on the upscalability part. So we are also asked that very soon. And indeed, it's very important to have some collaboration with equipment supplier. I think their equipment supplier, again, today, the there are a lot of expertise in Europe, but maybe they are not used at their full potential. So create some connectivity between startups and equipment suppliers to develop new process is very important, is really critical actually. And of course, the cost, of course, very important, but I would say, of course, there are different aspects and three key drivers I want to mention. Of course, your raw material is important. So the ingredients, your bill of material will have an impact. Then the process again, so there the dew points, the temperature of your process, the process use, it PVD, is it wet process, dry process, all of that will have different aspects. And again, solid state is not one story. It's depending if you have sulfide, if you have oxide, we have different type of chemistry. We are much closer to the classical, let's say, process of lithium-ion batteries. Which is one of our advantage, but basically this will all have an effect on your cost. And ultimately, of course, we will not be competitive. None of the solid state will be competitive until we have gone to the giga scale. But what we have decided at Solitor, at least strategically for us, we never want to become a gigafactory. So for us, we see our business model is really to develop a technology, show the upscalability, but we want to partner as soon as possible with cell manufacturer. Actually, we don't want to be a cell manufacturer. We want to leverage on their expertise to faster our roadmap and our development process. So that's, I think, what makes us slightly different from other startups, that we really want to, from the start, partner, because we cannot do it all. At the end, we have to focus and our resources are limited. So that's something we want to work with a licensing model and to remain capex light as much as we can. Of course, we will not be fully capex light, but we have a pilot line here in Belgium, but we will try to keep it, let's say, to a pilot line and to, as soon as possible, work with, and that's what we are working on now, to try to set up strategic partnership to, as soon as the tier level is increased, we can transfer it to our partner. I hope I answer your questions.
Yeah. Yeah, no, it's like, I mean, it is very, very interesting, Fanny. Thank you so much for sharing. Of course, everything is important, but there is an order of things, and that was it's really interesting how you juggle all these ones. You mentioned also a lot of stakeholders. Thomas, in the current coalition, who do you have involved? Is it covering all those stakeholders? And what is the broader view on this question of what we want to achieve in terms of performance?
I think it's really linked to what Fanny said, but maybe before answering your question, Wouter, I will jump and maybe answer your question at the same time on what Fanny said. We expect from European companies and European players to be perfect technically. Investors expect this from them, but then we expect them to be cost efficient as a Chinese, as the external people tomorrow, while we are doing this with less people, less money, less private money, and in the current financial landscape with the financial market and so on. I mean, it's not so easy. So you need to have the public funding coming heavily now to de-risk all this. But how, and maybe now answering your question, how to do so? By funding European players. So in the coalition, we have advanced materials players in Europe, cell manufacturers from Europe, OEM from Europe, but also equipment and machinery providers from Europe. And this is very important. We need to learn from the previous mistakes, and it's okay to make mistakes. I think in the last 15 years, 20 years, I think the Chinese made a lot of mistakes. But when they made these mistakes, they did not say, oh, let's stop everything, which is sometimes what we can hear now in Europe. We had one difficult situation. Should we continue? Should we keep the level of investment at the same level? Of course we should. How you will achieve, how you will succeed if every time you fail, you stop? I mean, it's not possible. So now, after the situation we are facing, we need to look seriously at this situation, but keep investing, keep supporting companies, startups as Solitor, but also larger industrial partners to make sure that they can be competitive They can provide the right technology for the right applications to the European economy, because we are talking about this at the end of the day. We are talking about independence, jobs, economics benefit for the whole continent. We can outsource everything to others, but I don't think on the long term it will be beneficial. We should maybe focus on long-term grid and forget short-term grid, because yes, of course, we'll need a lot of cash, we'll need a lot of efforts today and tomorrow to make sure that on the long term we can sustain.
Yeah, a lot of effort needs put in. Johan, of course, always in these settings, you're the one from the commission, so everybody looks at you for the money. But of course, there's a lot of effort also going on the member state level, regional level. How do you see the coordination between all those efforts going forward?
Well, just a quote from the Letta report. I think he said that there's two types of member states: the ones who are small and the ones who don't know yet they are small. And I think that is something to keep in mind. No single member state can even pull this off by itself, and we really need to work across the boundaries, across the frontiers, and come together at European level in order to make something like this happen. Because, as Fanny pointed out, and Bozorg also mentioned, we're up against a real juggernaut who has a lot of means at its disposal. So we need to coordinate across not only the Commission services, but also with the member states. At one level, we have the set plan that is currently under revision, and that really sees a bigger role for the member states, more coordination and more mobilization of member states' funding. But when we look towards the near future, well, first we had the IPCEIs that are tools that have mobilized state aid in two really big projects aiming at batteries. Jointly, they have mobilized 6.1 billion of state aid. In March of 2023, we had the establishment of this TCTF, the Temporary Crisis and Transition Fund, that has its roots in mitigating the economic impacts of the Russian aggression towards Ukraine. So until the end of 2025, this allows the member states to provide state aid to help the transition towards net zero economy. And that includes also support for the manufacturing of strategic equipment, including batteries. Now, the Clean Industrial Deal is now in full development, and part of that is replacement of this TCTF by a new instrument, the Clean Industrial State Aid Framework, or the CSAF. Actually, the public consultation for this new instrument is open until the end of this week, so maybe we can point towards that in the chat. The intention is to have this CSAF adopted in the second quarter of 2025, and it will be in place until 2030. And this will include measures for de-risking private investment and also supporting sufficient manufacturing capacity for clean tech. And again, this is a big opportunity for batteries. So I think there's certainly something moving along these lines in mobilizing the resources of the member states and having all the noses point in the same direction.
Okay, clear. Yeah, okay. New developments there as well that we might be piggybacking on with this technology. Let me. We have 12 minutes left. Let's quickly dive into some of the questions that have come in. First one for Gwen, I think. What about the life cycle? Like we heard about a lot of the KPIs, but what about the sustainability part and the life cycle? What's the recyclability of these materials, and are there specific challenges there? Is it too early to think about that? What's your view on that?
I don't think it's ever too early to think about it.
Mhm.
Especially if you look at some of the solid state chemistries, there's definitely materials that are critical in there. There's definitely things we have to think about value chains. There's going to be certain things we can learn from lithium ion in terms of the recyclability, but we're going to need no whole new processes. So there's a couple of the EU projects that are looking at recyclability already. One in particular is looking on how to deal with the lithium metal, how to get the lithium metal out of the cells so then you can deal with the rest of the cell in a safe way. But I think in general, it's never too early to think about sustainability. It's never too early to think about recycling. This is one of the chances, I think, for the EU that we can definitely move ahead in this regard, because we do look at it early. And so in general, I think people are looking at it. It just needs to keep kind of going with the manufacturability and with the manufacturing and everything else. Yeah.
Yeah, very clear. Okay, so yeah, just think about and don't forget about it now. Just we need to also pay attention to that while also trying to tick all the other boxes. Maybe next one for Fanny. You told that you're having to build this strong executive team. How do you address the challenge of finding qualified talent? And are there specific profiles that you look rather more for than others, for example?
I would say so far we have been, of course, looking mostly in our network, I would say, from the previous CEO, the current CEO, myself, and to find the right people with expertise from industry. I think this has been our way of managing to build the team we have today. But of course, yeah, if you ask me what type of profile are we looking for? Yeah, again, industrial expertise, people who have been already working in larger factory. And I would say today it's slightly different. I mean, we have happened to, of course, Norvolt. There are more people available today who were actually several years working for such company. So today it's quite different actually compared to 3 years ago. So we have a slightly different market and access to, let's say, talent today. But maybe it's only, let's say, also for a certain period of time. We also see that people from US potentially now are looking to go back to Europe. So there are different dynamics given the geopolitical conditions. So yeah, I think that's quite you have to adapt all the time, let's say. But now it's better than 3 years ago, I would say.
Yeah. Okay.
If I may say.
Yeah. Exactly. Yeah. The market opportunities have changed in that sense for you. Also, a small plug that if you're interested in these kind of discussions between the policy side and the research side and trying to push forward the state of battery technology, there's also a job ad open on the BEPA website if you want to join our team in Brussels talking about this. So check that out. Deadline is also for this Friday. Maybe last content point. I'll start with Ben and then maybe go to Fanny. We are building this value chain. We're slowly building it up. We still need to set steps in all the different parts. But do we have already an idea of what the manufacturing costs can be, or do we first need to learn to walk and then actually we can calculate how much it actually will be in terms of end value for the product?
So should I start?
Yeah, please do.
I think we sort of have two different scenarios. We have the one that Fanny mentioned of solid state batteries, or let's say somewhere along the spectrum of solid state, that's much closer to lithium ion production methods. where you can more or less adapt the processes to a solid state chemistry or a semi-solid state chemistry or something along those things. In this case, probably we could move in that direction. There's certainly things that have to be figured out yet, but maybe here you could start working towards manufacturing costs. For some of the other true solid state chemistries or using completely new manufacturing processes, I think, as you mentioned, we have to learn to walk first. We have to figure out how we can scale up these processes. How is this going to look like on an industrial scale? And we have to, let's say, use the expertise that's being built up at the RTOs in order to answer some of these questions. We're seeing the RTOs are shifting a bit from not only the fundamental side, but also to the how can we do more in terms of upscaling. You're seeing pilot lines, you're seeing new material manufacturing pilot lines. So not, let's say, the cell production, but also the material production, where research institutes, of course, with public funding, are investing into these types of things. And that's also going to give us a basis to get an idea of where the manufacturing cost can go, because these facilities are going to be available. And so this is a place where funding for the RTOs is also helping to put all of this together to figure out where we're going to be in the coming years.
Then maybe pivot this question then to Fanny. Are you able to build on these expertise and of the RTOs and leverage it, and or what are your other ways to work on this issue of the manufacturing?
I think in the course there is also, I mean, I completely agree with Gwen. There is really two paths. I think you can put almost the battery sticking as close as possible to the lithium-ion battery. We are there, and polymer battery, I would say, would be in that category. When you go more to oxide and sulfide base, you are really going to other type of processes. I mean, so I fully agree with that split. Of course, the lithium metal, but again, you have lithium metal, lithium free, so you will have very different way of handling and doing all of that. So you can again put subcategories there. But I think one thing we forgot is today lithium-ion battery, they are produced, they take 3 days more or less at end of life to create the solid electrolyte interface. So you have 3 days where your cells are built, and you still have in the factory to prepare, to precondition them. And honestly, for solid state battery, this is not obvious that it will remain like that. So if we can manage to cut time or even remove that step of preconditioning of the battery, you can also make huge cost reductions for solid state battery. I'm not saying it's possible, it has to be investigated, but I think a big part of the cost could be reduced there in terms of CapEx. You will not need all these temperature chamber, these cycling machines to precondition your cells. So it's less CapEx, less OpEx. And potentially you can reduce a lot of the cost of the battery manufacturing on that. So that's something, for example, we are looking at. And of course, we are trying to set up also a project to look more in detail on that. Do we need a formation cycle for that battery? Not. What are the implications on the performance and on modeling those? So yes, indeed, there is a lot to be discovered there, and potentially some cost reduction can be achieved there as well. Beside the process, of course.
Yeah. Okay. Yeah. Very, very clear and very interesting to see where we can actually improve. Not only have to adapt current lines, but actually make leapfrog in that sense. What's currently being done. So with that, I want to thank all of the panelists, Thomas, Johan, Gwen, and Fanny, for their participation. I want to thank Bozorg again for his presentation, and I want to thank everybody who has joined us. Please let us know if there's any more questions that we can help you with. I think many takeaways here. It's a very strategic technology for Europe going forward on multiple dimensions, which really requires support. We just need to see how we can leverage it, how we can tackle the bottlenecks that are out there, even though they're There's multiple roads leading to Rome, different kinds of chemistries, different kind of manufacturing strategies that we need to find out which ones will work here, which ones we can build the full value chain. So still a lot of work to be done. I wish everybody the best of luck and best of support who are working on this, both from the funding side and from the scientific side. With that, I want to close this tech talk for batteries from BEPA. Next meeting will be probably in around June 9. Then we will go deeper into the stationary batteries for the grid. Where are we there? What are the kind of technologies that Europe needs there? So please join us for that one. For our BEPA members, we have on the 28th of April a specific session on how the IPCI work. So we already mentioned name checked in this session as well. If you're interested more into those, join us on the 28th of April for that one. But for now, I wish you a very pleasant morning and see you at the next BEPA webinar. Thank you so much.
Thank you. Bye.